Waalaikumsalam. Selamat hari doktor.
Okey, sekejap Kejap ya, saya punya another device ni tak boleh connect lagi dengan internet. Sekejap. Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and very good morning. Is it clear my voice?
Clear, madam.
Clear, Doktor.
Okay. Right. Okay, before that, last time we have tried for example 2.5, which is under undetermined coefficient, right? Second order non-homogeneous. Okay. Again, I would like to give some explanation about second order non-homogeneous. Okay. Under second order, okay, uh, second order non-homogeneous linear differential equation with constant coefficient. Okay. So for second order non-homogeneous linear differential equation with the constant coefficient can be constant, okay, general constant like A, B, C, or it can be, coefficient can be constant like A, B, C, or it can also be variable coefficient, such as if the differential equation, we differentiate for y, so a variable coefficient can be like x, for example. Okay, so and then under this second order non-homogeneous linear, okay, we can use two methods. The first method that we have learned before Hari Raya, which is undetermined coefficient, and then this week we will learn about variation of parameter. However, okay, before that we just go for undetermined. Example berapa 2 point, sekejap, 2.4. Okay, we went through 2.4 and example 2.4, 2.4 and 2.5. So today I would like to go another example for undetermined coefficient, which is you need to have a different point of view to solve this question. Okay, but this example has in your module example 2.7. For those who have module, please refer example 2.7 page 46, right? Example 2.7. Okay. Alright, class. This example 2.7. Okay. The question is, sekejap, nak record. Okay. Sekejap. Allah, cancel. How to stop record? Okay. Kejap 1 minute. Okay, sorry. Okay, example 2.7. The question, find particular solution solution meaning that you need to find for the constant, find value for the constant in the equation. Okay, find particular solution for initial value problem for y double prime minus 9y equal to x plus exponential s with initial condition of y0 equal to y prime 0 equal to 1. So meaning that when x0, y equal to 1. Y equal to 1, y double prime also equal to 1. Okay. Step number 5. I'm not sure whether you still remember for the step. Okay. Step number 1, you need to find your YC. What is your YC? Okay. For corresponding homogeneous equation, YC, what is the value of YC when the equation when fx equal to 0? Okay. In this case, okay, fx not equal to 0 because this is non-homogeneous. But for this first step, you need to find for homogeneous. So here, these two are constants. Okay. These two named as is this. Okay. Not constant, we call it coefficient. Is this variable coefficient or constant coefficient?
Variable.
How about others? Boleh faham tak? Okay, kalau like A, B, C, these are constant, we call it, sometimes we just name it as constants, but this is constant coefficient. These two have X. So these two are variable coefficient. Okay. So y double prime minus 9y equal to 0. You just use your calculator. Okay. You will get two different values, two different roots. Okay. 3n minus 3. So this case, if you refer to the table, this is the first case, case number 1. So that your yx in form of this. Okay. So M1, M2, yeah. So it starts with A exponential M1x plus B exponential M2x. Okay. So this tak kisah sangat. Okay. Not really critical because it's up to you if you want to declare your M1 equal to -3 and M2 equal to 3. Okay. Both still correct. So second step, find particular integral yp. What is your yp? So yp, okay, for non-homogeneous here, the first one you need to look at for yc, and then fx on your right hand side is fx. You need to look for your yp. So for your right hand side, yp. So based on your fx equal to x plus exponential x. So here you need to refer to table 2.1. Okay. Check your table 2.1. Table 2.1. Okay. So in this table, your fx equal to x plus exponential x. So x plus exponential x. So you need to find one by one, one by one. So x. So from number 1, 2, 3, 4, 5, 6, which one that you think very similar, okay, with this column? If your fx equal to x, we focus on x first. So which one?
Polynomial, the second one.
The second one, polynomial, and which one? 1,
That's
2, 3, 4.
the second one.
The second one. Yes, because it has x. So x, k here in this case, k can be 1. Okay, so kx, so that you can assume your yp equal to cx plus d. Right? So for the second one here, exponential x, look at the table.
The first one, madam.
The first one, exponential, yes. Okay, class, siapa lagi not very clear about how to choose or how to assume YP when refer from this FX? Anyone need more explanation on this? Siapa lagi yang tak boleh lagi? Ada tak? Tengah beraya you all ni. Muhammad Alif. Okay, Alif, do you have any question regarding this table?
No, madam. No, doctor.
Habis yang angkat tangan tadi?
Tertekan. Sorry.
Dia nak jawab, saya tanya siapa berhari raya. Okay, next. So we will use cx plus d and then c exponential and x. Okay. So class, here. Mana tadi? 2.7. Okay. We know that. Sorry. Okay. For x here, okay, cx plus d. For exponential x is c exponential and x kan. So become c exponential and equal to 1. So c exponential x. But class, please do not write c repeatedly. Since for x you have cx plus d, so the following constant become e. Okay, so this c become e exponential x. Okay, if you write c for the second time, this will conflict with this cx. Okay, just use use constant continuously. Right? So this is very important. Okay. Some students uses same constant repeatedly and then they got a different answer. Okay. And then the second one, check if YP has a same pattern of the YC. So YP you have here, and then this is your YC. Okay. You need to compare whether these two have similar pattern or not. Same or not the pattern. Okay. So YP Cx plus D plus exponential E exponential X, and then AE exponential A exponential negative 3x plus B exponential 3x here. So, and then, so not similar, not same. One, even if for this part same, okay, but this Cx plus D, this part is different to YC. So, since YP and YC has no similar or the pattern not same, so the final YP become the YP that you got just now, right? Just take the value Cx plus D plus exponential E exponential E, right? Class, let's say if the pattern YC equal to YP, what you need to do?
Multiply YP by X.
Yes, correct. YP or YC by X?
Or
YP?
YP,
YP.
doktor.
Huh?
YP, doktor.
YP. Kenapa YP? Not YC.
Sebab YP yang kita nak cari kot.
Yes, correct. Betul. Because second step ni kan YP. If you multiply X to YC, you will change the value of YC. But YP yang kita cari ni, we focus on YP. So, tak berubah kan nanti. Okay. QE nanti kalau dah multiply X pada YC, walaupun you dapat different, tapi dah salah lah. Okay. Macam ada 2-3 orang je dalam kelas saya. Yang lain tengah makan kuih raya Tak achieve betul lah. Yang lain okey ada? Daniel?
Okay.
So, next. Since kita dah dapat final YP, so and the next step kita, we need to find YP and YP prime and YP double prime. Banyak sangat YP prime ni kan, pening saya. Bukan pening ni, macam tersasul. Okay, YP prime and YP double prime using product rule. Okay. So, by using product rule, dapat tak? You all dapat tak ni?
Dapat, madam.
Dapat. Ni modul dapat, tapi have you tried? Have you tried for this?
Belum, doktor.
Yes. Tapi dia kena guna product rule lah, madam. Macam differentiate je kan?
No need actually. Sebenarnya differentiate je. You don't have to go for product rule. Betul Sebab you differentiate these two saja, you will get YP prime, and then you differentiate C plus X, E exponential X, you will get this. Okay. Then next is substitute YP P prime and YP double prime into the original equation. Okay, refer to the given equation and then whatever Y here, you need to use YP. Because we just complete steps for YP and then whatever YP prime, YP double prime, you substitute in the original equation. So Y double prime is, this is Y double prime minus 9 YP. So this become YP double prime minus 9 YP equal to X plus exponential X. Okay. Right. So new your YP. Okay. After that, you need to do equating coefficient. So refer. You need to check both sides. So you can choose in this case. Okay, this module used to choose CX here. So CX coefficient here, variable coefficient is X. Okay. CX here, okay, equal to negative 9C equal to X. 1X. Okay, so you will get C equal to negative 1 over 9 straight away. After that, okay, X to the power of 0. Okay. Or this is 1, but we not using 1, we use exponential, X to the power of 0. So X to the power of 0 meaning that you have constant coefficient. Okay, here is constant coefficient. Okay, so constant coefficient is negative 9 multiply with D equal to on the right hand side. Okay, right hand side here has no constant, so equal to 0. Okay, and then exponential X. Okay, for exponential X coefficient, so you have E. Okay, exponential X, okay, 9 E. So negative 9E equal to 1. 1 due to this. Okay. So E you will get negative 1.8. So YP equal to negative negative 1 over 9x minus 1 over 8 exponential X. Okay. Ada apa-apa soalan tak? Ni dapat dari mana? From YP equal to CX plus D plus E exponential X. Okay. Right. So step number 3, find general solution. General solution, you need to combine both YP and YC, add them up, sum up for YC, YP. So now you have your YC in form of apa ni? Ni masih ada constant lagi So what you need to do, since you combined y, x, it still has constant because in this question, the question asks you to find particular solution. So you cannot have equation in form of A and B or in form of constant coefficient. So you need to settle everything. So number 4, apply initial condition to obtain particular solution. So y 0 equal to 1. The value is given in question. So when x equal to 0, y equal to 1. Okay. So this from the general solution. So masukkanlah. You need to substitute yx when x 0 equal to 1. Okay. Exponential negative 3x. So a exponential negative 3x equal to 0. You will get a only because this will be exponential 0 equal to 1. So a plus is also same plus b and then plus here. So 1 over 9 mana dia pergi? Okay, because x equal to 0. Okay. So if you rearrange this equation, you will get a plus b equal to 9 over 8. So yang ni you kena buat persamaan serentak. Okay. So and then differentiate yx with respect to x, then apply initial condition. Okay. That's why initial condition given two values. Because first, you can solve. This is especially for you if you have two or more constants. If you have only one constant, you will straight away get the value. Okay, that's why initial condition given two values. Okay, because you have two constants, right? So for y prime 0 equal to 1, first differentiate ys with respect to x, then apply initial condition. Ada apa soalan tak?
Tak ada, madam.
Okay. Y prime. So y prime x, just now you have y prime 0 equal to 1. Betul kan? Equal to 1. Okay. Y prime x equal to a exponential 3x negative 3x plus b exponential 3x minus 1 over 9x minus 1 over 8 exponential x. So you just okay. Sekejap. This part a plus b 9 over 8. Masukkan value lah. Okay. y prime. Okay. Y prime, this is macam salah tulis je ni. Betul. Okay. Differentiate. Okay, differentiate. That's why -3, a exponential -3. Differentiate exponential -3x. Okay. Same goes to b. B exponential 3x. So differentiate this, you will get 3b exponential 3x. Okay, after that you differentiate this, become 1/9, and then this exponential. Okay. Right. So, how can equation become like this? Because y prime 0 equal to 1. Okay, this is 1, and then okay, for this part, it change to x equal to 0. So exponential 0 become to 1. So what we have left, -3a plus 3b minus 1/9 minus 1/8. Okay. Okay, so you need to rearrange. Okay. Boleh Any other question? Any question so far? So solve for simultaneous equation. Okay, A and B. Ni persamaan serentak. Masa saya belajar dulu-dulu lah. Okay. And then A you will get 77/216, and then B 83/108. Therefore, a particular solution given like this. Still like this. Okay. Ada soalan apa-apa?
Setakat ni tak ada, Doktor.
Okay, can we have break 5 minutes? After that, saya nak saya yang ini. Sekejap. Okay, nanti kita tengok example 2.8. Okay. Saya will go through quite fast for 2.8, and then we go for variation parameter, because this is under undetermined coefficient. First method, and then second method we go for variation parameter. Break 10 minutes. Tak lah, 5 minutes. Okay. Now we look at example 2.8. Okay, example, still use the same technique, undetermined coefficient, but here if you look at the question, find general solution for 4y double prime plus 4y prime plus y equal to 5x exponential negative half x. Okay, this is non-homogeneous, linear. Okay, linear, actually, if you find out that the degree, this is order, second order, but if you look at the highest order here is second order. For the second order, you look at the power of this. So the power of second order here is 1, so this is linear. If the power here is 2 or more, so it is not linear. Solution for the first step, YC for homogeneous equation, so you need to change your fx equal to 0 instead of 5x here. So again, now this case, okay, you have same, totally same root, which is negative half. So this is case number 2, second case. So yx must be in the form of a exponential m1x plus b x exponential m2x. However, this actually m. Okay, and then the second one, particular integral yp. So assume yp due to fx equal to 5x exponential negative half x. Okay, so cx plus d, okay, and e exponential negative half x. Okay, class here for x. Just now we example 2.7 we went through x plus exponential x. However, in this example 2.8, x dot exponential. So what you need to do, check one by one. For x, just now we have cx plus d, and then for exponential is actually c exponential and x. If you refer to table 2.1. So since this part, okay, these two coefficient be multiplied, okay, so just multiply, and then please do not use repeated constant. So since you have CD now, this become E exponential, and n is based on n here, so negative 1 over 2x. Right? So after that, you can continue with your basic maths. Okay? Multiply, plus and minus and so on. Right? So for this part, quite challenging because the steps quite long. So you can try yourself, and then the answer is Ya. Okay.
Madam,
Ya.
nak tanya yang dekat nak dapatkan YP tu kan,
Aha.
kan kita kena refer dekat table tu.
Mm-mm.
Lepas tu yang apa dia punya fx tu sama dengan 5x exponential to the power of negative 1/2x kan.
Mm-mm.
Apa yang jadi dekat 5 tu?
5. Oh,
5 yang kat
nombor
depan
5
tu.
ni. Oh, ni
Yes.
ada X kat sini kan? Okay, kalau 5 you nak guna K Maksudnya macam ni ke? So 5 ni actually kita letak kat luar ni aja kan? Kalau you nak try, maknanya, okay, saya pun tak terfikir. Sekejap. So you have tadi apa? 5 X kan? X exponential. Okay. So 5x. So kx. Oh ni. Allah Akbar. Bukan tak terfikir. 5x exponential. Okay. So 5x. Ni. Ni boleh ambil yang ini terus. X ke 5. Sebab X ni kx juga. But k equal to 1. So refer to this part. Kalau if you find out that your equation, okay, y double prime plus 9y equal to 5, and then fx here become 5, so that yp you can assume yp equal to c. Yang ini. Since you dah boleh guna yang the second one, you just guna yang kx ni sajalah.
Madam.
Ya.
Sebab apa yang saya faham kalau contoh kita ambil 5 tu, contohlah kita ambil 5 tu sebagai C. Lepas tu kita darab dengan KX kan. Kita darab masuk. C dia darab dengan C, lepas tu akan darab dengan D. So dia macam sama macam tadi yang dia akan ada sama same CE dengan C. So dia akan buang terus. Yang Madam buka page 49.
Okay.
Yang note atas ni kan. Sebab CE kan dia akan darab CE dengan DE kan. E dengan E dia sama. So dia akan jadikan dia sebagai single variable saja.
So, even if C, katalah D, dx plus E tadi kan? And then multiply tadi ada F apa tadi?
F
F
E
exponential kan?
exponent.
Kan? So yang ini dia masih akan jadi C dx plus CE. Betul tak? CE. For example like this kan? Ni exponential X lah, let's say kan? So yang this part dia boleh macam ni kan? Sama juga
Dia
lah.
akan betul, dia akan sama juga. Sebab
Because,
dia ada common.
sebab dia still constant kan? Right, saya tak perasan yang ni. Okay. Alright. Boleh Siapa tadi tanya?
Boleh, Madam.
Thank you. Sebab saya just focus on just now X plus exponential, now X dot exponential. So that's why constant, if you have a constancy ni, you can multiply plus tak boleh sangat depends. Tapi you can multiply with ln, for example, exponential, but it still becomes C juga. Okay. Thank you. Tadi siapa tanya Chan Chan, Chong, Lim, Loh. Tak sure siapa. Chan tadi dengan saya. Thank you. Okay. Now, I nak pergi, kelas kita ni tak terlalu lama I nak go for variation of parameter. So this is the second second method or second technique that you can use to solve second order but for non-homogeneous. Okay, so in this chapter 2, actually second order, the difference is homogeneous and non-homogeneous tau. Okay, so yang ni second order linear. Kita cover all of this course for linear only. Okay, so second order, linear, homogeneous and also non-homogeneous. Okay, so yang ini second method for non-homogeneous, which is variation of parameter. Class, before that, I nak tanya for section 8 do you have class on hari apa? Section 9? Khamis Thursday pukul 8. You boleh join tak? Kelas? Tak boleh. Tak apalah. Okay. You ada kelas Section 8. Do you have class on
Kalau
Thursday?
saya tak ada kelas. Saya
yang
boleh
ada
join
kelas?
yang kelas pagi tu.
Maknanya pukul you free section 9 8 hingga 10 pagi. Tapi section section 8 petang ni. Sebab petang ni saya ada sedikit urusan. Kalau boleh buat tetapi tak boleh lama. So example mungkin boleh pergi 1 maksimum 2 pun, takut tak boleh habis 2. That's why yang kalau boleh join, tak join hari Khamis, otherwise kita buat example yang sedikit je lah dulu. Siapa lagi hari section 8 please respond. Daniel section berapa? Saya bukan apa bila you tak respond whether either you still with us ataupun you dah pergi beraya ni.
Saya boleh join, madam.
Boleh join. Okay. Chong boleh join Khamis pagi. Lagi?
Saya boleh juga, madam.
Saya kau boleh tak nak seorang pun tertinggal tau. Daniel tak ada
Ya.
Daniel, section 8 atau 9?
Section 9.
Oh, okay. Kamaruzi? Saya panggil seorang ni, saya tak kira. Takut tak ada kat sini korang ni.
Section 9.
Hairul Ikhwan?
Section 9 juga.
Aisyah?
Saya section 8. Tadi yang saya jawab. Saya boleh.
Oh, Aisyah maaflah. Cik Bunga.
Tak apa.
Chan, can you join on Thursday?
Madam, saya section 9.
Oh, okay. Chong? Saya nak pergi orang
Saya?
mana? Tak datang Chong section?
Saya section 8. Saya okey je. Saya
Okey je.
Khamis.
Hari Khamis pukul 8 pagi tau. You need to wake up
Boleh. Saya tak ada
earlier.
kelas. Khamis tak ada kelas. Khamis memang free.
Tu Iman. Okay. Alright. Lim?
Saya memang section 9, madam.
Okay, so okay, Loh?
Saya pun memang section 9.
Okay, Amin bin Agus?
Ya Puan.
Section?
Saya section 9.
Okey. Azif?
Section 9 madam.
Akmal? Muhammad Nur Akmal?
Section 9, madam.
Oh, okey. Fikri?
Saya section 9.
Khairul Akmal? Khairul Akmal? Khairul Akmal pergi beraya Tengok, tu yang tak syok ni. Muhammad Nur Akmal. Sorry, Muhammad Khairul Akmal. Oh, tak ada rupanya. Khairul Akmal. Hari ni berapa bulan? 25. Muhammad Adam Ashraf?
Saya section
You section? Saya tak dengar lah.
9 doktor.
9. Aiman? Oh, maknanya kelas ni masih wujud kawan-kawan yang dia tak apa. Mungkin dia on je laptop. Adam Ashraf section berapa?
9 doktor.
Oh, Aiman, Adam? Oh, saya nak kena check macam gini lah next time for your attendance. Aiman, Adam? Aiman, Adam tak ada. Muhammad Alif bin Zulkifli? Muhammad Alif?
Madam, saya section 8.
Aiman, Adam?
Ya, saya.
Baru ada. Can you join pukul 8 pagi hari Khamis?
Boleh?
Tak ada kelas?
Tak ada.
Okay. Alif?
Saya section 8. Hari Khamis pagi saya tak ada kelas. Boleh je join.
Okay, boleh. Tu Adam Ashraf tadi tak jawab kan? Adam Ashraf jawab.
Jawab.
Sorry. Aiman Adam yang ni. Okay. Alif Zuhairi?
Saya 9 doktor.
Okay. Amir Rafiki?
9 doktor.
Fakih Haziq?
8.
Boleh join tak Khamis?
Boleh sebab saya tak ada kelas.
Alright, very good. Firdaus? Firdaus ada 2 ni. Firdaus yang atas ni. Firdaus Bemu. Apa entah Tak nampak lah penuh. Firdaus bin Muhammad apa entah
Suki ke?
Ya, Muhammad Suki.
Boleh je.
Boleh. Firdaus
boleh.
bin okay, thank you. Firdaus bin Zainal apa tak nak keluar.
Zainal Abidin. Boleh doktor?
Okay, boleh. Hafiq?
Saya section 9 doktor.
Okay, Hafiz Ramli? Okay, Hafizul Afendi?
Boleh doktor.
Okay, Hanan?
Boleh.
Aziz?
Boleh.
Haziq Nazaruddin?
Boleh.
Khairin Haziq? Khairin Haziq? Khairin Haziq? Muhammad Khairin Haziq. Macam tak ada je ni. Tak dengar ni. Khairin Haziq tak ada Oh, 2 orang tak ada jawapan ni. Tak available dalam ni sebenarnya. Tapi dia on laptop mungkin. Muhammad Takif?
Boleh.
Khairin Haziq ada? Mic rosak. Okay, boleh join Kamis, saya tak tahu awak session berapa. Okay, alright. Taki boleh. Zuhair?
Boleh, Dok. Boleh.
Okay, Petrus?
Boleh, madam.
Suzila?
Boleh, madam.
Okay, thank you. So, kelas kita petang ni saya bawa ke Kamis
Okay.
Okay, thank you. Saya bawa Kamis pukul 8 pagi. Kadang-kadang saya terlewat sikit pagi-pagi tu. Saya akan maklumkan lah. So, kita go for variation of parameter. Okay. So, ni tak ada. Variation of parameter here. Okay. The second order non-homogeneous linear D. Second order and then linear. Now under non-homogeneous. Okay. Under homogeneous, this is the second method or second technique, which is variation parameter. Okay. So the equation, standard equation can be used using variation parameter if fx consists of complex function such as ln ataupun sign actually not complex but complex using we have exponential right. So once you find out that your equation fx your fx consists complex function. What is complex function? Ln exponential. Okay, so you can use variation of parameter. Okay. Working steps in solving variation of parameter. Sekejap, saya tengok step saya ke step ni tadi. Okay. Lebih kurang saja. Okay. From A y double prime x plus by prime x plus cy x equal to fx, you need to identify what is your A and what is your fx. Saya rasa saya nak tulis jugalah. And then later on you can refer. So variation of parameter. Okay. So we have. Sekejap, kalau macam ni saya takut nanti you pun confused. I prefer to start with general one, second order, non-homogeneous. So you tahu you berada dalam which chapter and which subtopic. Linear, DE with constant coefficient. Okay. You can have two methods. The first one just now apa? Undetermined coefficient. Well, the second one is variation of parameter that we are looking at. Okay, so for variation of parameter, okay, the condition, okay, condition in order to use this technique, okay, right? So you have a y double prime x plus b y prime x plus cyx, okay, equal to your fx, sorry, okay, equal to fx. So fx, okay, if fx consists of complex function. Okay, example here is ln x sine exponential x, for example. Okay. So steps for this, the first one, from a y double prime plus b, it has x, yeah? Equal to fx. So what is your a? What is your fx? Okay. Second one, what is your yc? Yc based on homogeneous. Okay. After that, let yc equal to y1 plus y2. The third step, okay, Wronskian W equal to which is, what is W? But W equal to y1 matrix, y2, y prime, y1 prime, y2 prime. You need to find out what is the value of Wronskian. And then number 4, okay, U equal to negative integration of y2 multiply with your fx just now over a multiply with w, which is Wronskian, okay, and then plus a. So what is the value of your u? And then after that, first u, and then after that you need to find what is your v. Okay, how to get your v? You need to integrate just now y2, now y1 multiply with fx over a w dx plus b. Okay. The next step, as usual, you need to find general solution based on y equal to u y1 plus v y2. Okay, and then number 6, apply initial condition. Not to put your IC number pula ya. Raya-raya ni banyak makan biskut takut pening. So apply initial condition. Why? Okay, this is to get particular solution. Okay. Right. So difference here. So variation of parameter condition here you need to know based on fx. Okay, it must has complex function for your fx. Okay. Okay, so here for Wronskian case, here step number 4, 5, the difference here y2 and y1. Okay, and then Okay. Saja. So maybe we can go for the example. .9. Okay. So example 2.9 here, because this integration, maybe find here sin x. Sekejap For this example, I prefer to go and rewrite everything one by one. Saya dah lah tinggal ni based on my notes. Sekejap. Okay. I would like to go together with you here, not referring to module, but you can also write module, same thing, but I think for a smaller tips, okay, I have on my notes here, so I prefer to share with you together, and then you can also refer to module. But before that, I want to say first. Okay. So example 2.9. Okay. The question asks here, find general solution for 2d squared y over dx squared plus y equal to 4 sine x. Okay. So solution here. Okay. Two d squared y over dx squared plus y equal to 4 sine x. Bising pula sekejap Sekejap. Ni nak setting ni. Kalau saya tutup ni tak dengar pula Sekejap Wait dululah. Okay. For sine x. Right. Okay, step number 1. Explaining step number 1. You need to find a and fx. Okay. So when you refer to your equation here, okay, you can change the equation as 2y double prime plus 2y equal to 4 sine x. Okay, and then you look at these 2, 2, and 4 so that you can factorize or you can cancel out these 2 on your left hand side. So on your right hand side become 2. So this equation become y double prime plus y equal to 2 sine x. So in this case, okay, when you compare with your AY double prime plus BY prime plus Y, CY equal to FX, okay, because you have this, okay, you have this, so you can compare. So which one, what is the value of your A?
1.
A equal to 1, Fx equal to
2 sin X.
2 sin X. Okay. Right? So we settle for step 1. So step number 2, you need to find what is your YC for homogeneous. So homogeneous, here, how to write this? Ada dalam modul tak sekejap? Mana modul? For M. Okay. Ada M1, M2. So in general you can see that if you have Y double prime, this become M squared. Y prime become M to the power of 1. Y become M to the power of 0. Something like this lah. Okay. So here you have Y double prime plus Y equal to 2, cannot 2 sin X sekejap, tak apa. 2 sin X. Okay, but for homogeneous, you need to change your Fx to 0. So Y double prime become M squared plus Y here become 1. Okay, 1. So maybe I can change to 1. Boleh Equal to 0. For homogeneous consideration. Okay. So for this case, if you use your calculator, you will get your M equal to, dapat tak? Plus minus I. Okay. So bila plus minus I ni, refer table kan? Refer table berapa Case berapa ni? Case, so this is case 3, which is M equal to alpha plus minus beta I. Okay. So Yx become exponential alpha x plus, bracket A cos beta x plus B sin beta x. So here, okay, for M plus minus 1, what is your alpha?
0.
0.
Alpha 0. Beta?
One.
Ya ke? Betul lah. Okay, 1. Right. So, what is your Yx? ycx become exponential 0 x a cos 1 x plus b sin 1x. So this become finally your yc x equal to exponential 0 is 1. So a cos x plus b sin x. Okay. Right. So let, and then in the step, it has let y equal, now yc for the first one. And then the second one, let yc equal to y1 plus y2. So plus, refer to this plus Allah, plus here, plus here. So y1. So y1 here, cos, macam mana nak tulis? So y c equal to a cos x plus b sin x. So this become y1 sin x become y2. Okay. Cos. Sekejap. Allah. Ni. Cos x y1 sin x y2. Okay. Ambil yang itu je. A and B, tak apa. Leave it. Macam tu. Right? And then, so yc equal to y1 plus y2 equal to cos x plus sin x. Okay. So step number 3, Wronskian. Wronskian W equal to y1, y2, y1 prime, y2 prime. So W equal to y1, what is the value of y1? Cos x sin x. Okay. Y1 prime, differentiate cos negative sin x. Okay. Boleh, d cos x dx equal to negative sin x. So d dx sin x equal to cos x. Okay. Allah. Okay. So differentiate sign we'll get cos x. So how to solve your matrix? Multiply this minus this. Okay. So cos multiply cos become cos squared x minus, okay, Sine multiply with sine squared x, ada negative in front. So cos squared x plus sine squared x. Okay. So cos squared plus sine squared equal to 1. Okay. So step number 4. Okay. What is U and V? Okay. So U here, you need to integrate y to fx over a w dx plus a. Okay. V, you need to integrate y1 fx over aw plus b. Sorry, ada dx. Okay. So here, u equal to negative integration y2 is y2. Y2 is sine x fx. So look at your fx. Fx 4 sine, bukan 4 lah, fx tadi ni dah 2 sine x. So please highlight lah. So this will help you to refine your value faster. Okay. So sine fx 2 sine x dx over a is 1, w also 1 plus a. Okay. So negative 2 integration of sine multiply with sine squared x dx over, okay, tak ada over dah sebab 1 plus a. So that since you have this quite complex complex and has 3 goals that you need to have idea to solve. Okay. How can you play around with sine squared x here? Okay. You can use, if you still remember, we have cos A plus B equal to cos A cos B minus sine A sine B. Okay. But now, how about if you have cos A plus A? So this become cos A cos A minus sine A sine A. So here cos 2A equal to cos squared A minus sine squared A. All of this trigo semua guna trigonometric. So cos 2A, so cos squared A we can change to 1 minus sine squared A minus sine squared A. So this become cos 2A equal to 1 minus 2 sine squared A. So here, finally you can change your sine squared A here. So sine squared A equal to 1 minus cos 2A over 2. Okay. Here we go. Right. Then based on this, u equal to -2 integration of 1 minus cos 2x over 2 dx plus a lagi ni. Okay. Tak muat lagi. Cik lagi lah. Okay. Equal to negative. Integrate 1, you will get x. Integrate negative cos. Integrate cos, you will get sine 2x over 2. Okay. Plus a. And then finally you get negative x plus sine 2x over 2 plus a. This is for you. Okay. Now, boleh? Do you have any questions so far? Tak ada. So now we look at W here. Sorry, WV. Okay. So for V, okay, V equal to integration Y1 equal to cos X. Fx is just now 2 sine X over A is 1, W is 1, dx plus B. So integration of cos X sine X dx plus B. Okay. So here you need to use integration by part boleh kan? Okay. Right. So u equal to sine X du equal to cos x du dx. Okay. And then dx you can change to du over cos x. Okay. Equal to integration of cos x sine is u, dx is du over cos x plus b. Okay. Boleh? This from u is sin x, ni dx. Actually, for integration, by part you can use tabular table. You can use tabular table if you nak cakap good enough tak lah. Tapi but you need to understand that sine and cos function is are two functions that you will not get zero if because before you use tabular table, you need to have one of two functions that can be zero if you differentiate. Okay, so in this case for cos and sine, if you differentiate, this will alternately change sine cos. Okay, so that one for this case you cannot use tabular table, but you can use integration by part. Okay, right? So two integration of u du plus b. Okay. In this case, you can cancel out this cos. So become 2 integration u, you will get u squared over 2 plus b. So u squared plus b. So that v equal to u squared. U is sine. So sine squared x plus b. This is your v. Okay. And then step number 5. You need to find general solution for y equal to uy1 plus vy2. Okay, y equal to negative x plus sine 2x over 2 plus a the u betul tak u tadi? Okay, uy1 y1 is cos x plus v is sine squared x plus b. Y2 is sine x. Okay, so this u v y1 y2. So it's very clear for you. Okay. So y equal to negative x cos x plus sine 2x cos x over 2 plus a cos x. Okay. And then plus here meaning that plus Allah. Plus. Okay. Plus Vy2. So jadi apa? Sin cube. Sin cube x plus b sin x. Okay. I did not start dekat module. Okay. So for sin, now sin cube ni quite maybe this part you need to consider more. Okay. Based on this, just for us to refer. Okay. So for sin here, for sin 2x cos x over 2. Okay. We know that sin, note here that sin 2x equal to 2 sin x cos x. Okay. So we can change it to, okay, so sin 2x cos x over 2 equal to 2 sin x cos x multiply with cos x over 2. Okay, so 2 we can cancel. So sin x cos squared x. Okay. So for sin x cos squared x, we know that another note that cos squared x equal to 1 minus sin squared x. Right? Macam quite challenging to solve this trigo. Okay. Now this becomes sin x 1 minus sin squared x. Okay. Masih dengan saya you all? Masih
Okay.
Finally, this becomes sin x minus sin cube x. Was x over 2. So y become until here, and then y become negative from here. Okay. Negative x. Okay. Cos x plus sin Okay, now for this part, okay, we try to solve this. Okay. So sin cosine kau pada video tengok pun you akan macam pening juga Okay, so for sin x, we have settled for this. This becomes sin x minus sin cube x. Okay. Plus a cos x plus okay. Sin squared je sin squared yes, sin cube x plus b sin x. So in this case, sin cube we can cancel out to become negative x cos x plus sin x. Okay, sin x here we just copy it for this x cos x, and then after that sin x we can find that sin x, another sin x here, okay, attached with b, so sin x multiply 1 plus b plus a cos x. Okay, so now how to write? Okay, until here still correct, but how can we write in better way? Okay, so normally we start with a constant here. In this case, but sometimes a single constant you can put the last. Okay, but now we have a constant attached to your trigo. So we start with a cos x. Okay, a cos x, and then find b, find 1 plus b sin x. Okay, after that minus x cos x. So this is your y. Okay, general solution. So for this part, was quite long, the steps. Okay. I put in a bigger box. Okay. This is general solution. If initial condition given, you can find what is your A and what is your B. Do you have any questions so far?
Madam,
Ya.
kalau kan ni kita nak dapatkan general solution yang paling last tu kan? Tak boleh ke kalau kita tinggal jawapan dia yang ada sin cube tu?
Cop. Alamak, jap. Saya terpadam. Tak boleh ketinggal dalam?
Yang jawapan yang ada sin cube tu.
Ni.
Ah.
Boleh, tapi
Tak,
lagi...
bukan. Yang sebelum ni.
Mana? Ni. Ni.
Tinggal jawapan macam ni je. Tak boleh.
Boleh, tapi ni macam ada pendaraban, kalau macam ni nampak macam simpler lah kan? Sebab ni sin cube tau. Sin cube pun macam still selalu kita jarang tinggalkan dalam cube-cube ni tau. That's why datangnya function of trigo tu. Tapi kalau you dah cannot, kata orang, alamak I cannot go lagi lah. Kan? Tak apalah. Sometimes students have no idea how to solve this tau. But kalau I tak sure, ada tak for those who have hard copy module, you ada nampak tak trigo function dengan hyperbolic function dekat page 162? Ada tak? Boleh tak respon?
Ada
Ada.
doktor.
Ada kan? You can refer to that trigo, but sometimes I know that when you sit for your examination and then you blur after that, you memang dah tak boleh nak continue. Tak apalah. And then but you maybe you akan hilang few marks lah dalam final answer 1 markah. Okay. And then jalan kerja mungkin 1 or 2 marks.
Ada.
That's why macam sometimes saya bila saya tengok semua orang macam ni lah, banyak student tak dapat buat, saya terpaksa buat balik skema tu. Okay. Supaya you dapat markah kan, tak adalah hilang banyak sangat. Tak apa, tak buat yang mana mampu lah. Apa tadi siapa nak tanya?
Chan.
Yes, Chan.
Madam, masa test tu formula trigo ni bagi ke tak?
Sebab soalan belum finalize lagi, saya pun tak dapat tengok kertas soalannya apa macam ni kan. So, saya rasa dia bagi kot kalau berkaitan. Kalau very simple dia tak bagi tau. Okay. Very simple tak bagi, tetapi to me macam yang ini dah another level lah kesusahan dia punya difficulty tu. Rasanya bagi. Melainkan very simple lah. Okay? Ada question? Do you have any question so far? Tak ada. Sekarang pukul? Pukul 1. Hah? Pukul 1. 1 suku. Okay, alright. Alright. Pukul 1 lebih. Okay, I give you 10 seconds. You have any question, you can ask. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, kelas. Okay, again. Hari ni we have no class 2 to 4, no class. But our class 2 to 4 will be replaced on this Thursday. Thursday, berapa bulan? Berapa bulan ya? 27. Okay. 27, 8 to 10 AM. Okay? Alright. Itu sahaja. Okay. Itu saja. Thank you everyone. Nanti I will share this note. Bye. Assalamualaikum. Selamat Hari
Thank you,
Raya.
madam. Thank you, madam.